Has everyone signed in and everything?
Yeah, I think so. Oh, I gotta turn on the image though.
Yeah.
Okay. Okay. Well, when you're ready, mate.
Alright. Everyone's here, right?
Yeah.
Okay.
Thanks for coming out so early, guys. This is Dom. He's going to be running this crash course for you.
Yeah. Okay, hey guys. So my name is Dominic. I was with CEVSOC a couple of years back, and I'm just coming back to do a bit of a crash course for 2101. So I'm assuming most of you guys are like first and second years doing this course, right? Guys, if I could just get your attention, please. I'm assuming you guys are like first, second year level? Yeah, okay, cool. So this crash course is just going to give you a bit of a high-level overview of what's to come for the course. So feel free to take notes if you'd like, but I'm not going to go into any detail about how to do the calculations or any detailed information on the course, okay? So it's just a high-level overview of like how this kind of fits into your civil engineering career later down the line, okay? So this is a core course. So you are doing construction as one of the core courses, and it's just one of the parts of civil engineering. So civil engineering is kind of broken down into two major groups. So you do design and you also do construction. So this course is specifically about construction, where you'll build things on site rather than design and do the calculations to make sure things don't break. Okay? So in design, you'll learn that in third and fourth year mostly. For construction, it's a lower year course basically. So you'll do it in first and second year. So 2101 and then also 3101 after this course. Okay, so what are you actually going to learn about in this course? You'll learn about the different processes that happen on site. So how to actually build things from the ground up. You'll learn about the documentation as well. And you'll also do a little bit of quantity estimation and cost estimation. But that's mostly just calculations. If you can multiply things together and add them together, you'll be good, okay? What you actually don't learn about is any of the structural design. So if you don't like doing complicated calculations, you won't have to do that in this course. The most difficult thing is like you're multiplying numbers together, finding an area of a rectangle, finding volumes, things like that, okay? You also won't learn how to get along with tradies, so you will need to learn that on site. Okay, so 4 things that we need to consider in construction are safety, quality, cost, and environment. So these things are important because we want to make sure that things are built to spec and also are as cheap as possible, okay? So in engineering, you're trying to kind of min-max the cost of things, right, and make sure that it doesn't collapse, essentially, okay? Okay, so what your course is going to be about, you have 10 weeks with Flex Week in the middle. The first half of the course is actually going to be about building things, and then the second half is going to be more so about documentation and calculations on depreciation, cost, etc. So, the first half is what we're going to focus on today. So we're going to focus on demolition, earthworks, concreting, temporary structures, and permanent structures. So I'll just briefly talk about what each of those things are. So if we think demolition, we're breaking things, and we're making sure that we're breaking them safely so that we don't damage surrounding property, you don't injure people, things like that. Earthworks, if you think about Minecraft, you want to make a hill really flat, you have to mine out all the dirt and then level it. That's what we're doing in real life. Concreting is really, really important, and you will do a design course on this. Concrete is the second most consumed substance on Earth after water. It's very, very common in construction, and it's probably the main building material out of everything. Temporary structures allow us to build permanent structures. So they're usually made of wood or aluminium or I think that's it, yeah, wood or aluminium. And they're used to kind of form things up and hold it in place while you pour concrete or you put other things up, okay? Things like scaffolding as well allow access to buildings for people. Permanent structures are what happens after you remove all the temporary structures, after you've built up things. So think your structural elements, your columns, beams, things like that. And then for the second half of the course, it's mostly going to be calculation on cost and ownership and things like that. We won't really touch on the second half. I'm just going to touch on this first half for today. I think that's the most important part and the most realistic for on-site use. Okay, and specifically concreting is probably going to be the most talked about topic for today. Okay, so before we get on to actual building, like doing a job, all right, I've got a bit of an example for you guys. I'm going to talk a little bit about the construction process and then about how we actually do things in the real world. So there are three kind of big processes, right? You might have Transport for New South Wales as a client and they need a job that needs to be done, right? So if they have a job, they will contract that job out. They don't necessarily do it themselves, okay? So to start off with, designers will create drawings for the construction, right, to actually build the thing. The client will come back and have a look at it, review all the drawings, review all the processes, make sure it looks good to them, and make sure they have a cost in mind as well. After that, they will allow what we call a tendering process, right? So if they allow for a tendering process, contractors can bid on the job, and anyone can do that, right? You bid on the job, and then the government will have a look and see which one is the best cost, best value, best construction quality, etc. Right? A lot of the time, though, in real life, to be honest, it's the lowest cost who wins, right? Unfortunately, it's not necessarily always done well, but it is the lowest cost. Okay. Contractors then pick up that job. If you win that job, you have to fulfill it completely, right? If you have people in-house, like you're a big company like Lend-Lease or CPB or John Holland, you may have people in-house that you can have do the job, right? You have engineers, you have tradies, etc. If you are a smaller company, you're doing a smaller job, let's say you can only do one part of the job. You can still take that job on, right, as a contractor, and you can subcontract out some of the other work, right? Let's say you don't specialize in steel works. You can subcontract that out and just do concreting, for example. Okay? So some companies specialize in certain things. Okay, so in the real world as a contractor, this is how you actually complete a job, right? So there are 5 steps to this. You need to figure out what the job is. You need to figure out how to complete the job, calculate the quantities, calculate the costs, and then actually win the contract, okay? So what does this actually look like? Usually there are tendering websites, right? When you go into a workplace, you have tendering websites like Estimator One, for example. You go onto that website and they'll have contracts that they invite you to. You can have a look and download all the documents, all the files to be able to have a look at that job and see what needs to be done, right? If you can only do certain parts of it and you don't want to take on the whole job, you can just bid for that certain section. You can just tender for that certain section, right? When I'm talking about calculating quantities and costs, they have to do with calculating the amount of stuff you need on site, materials, also excavation, demolition, things like that. Cost to you as a contractor as well, and then you can add your profit margin on top and then send that in as a tender, okay? So this is going to take up the majority of the time. We just want a contract, right? So you're sitting in your office, you just want a contract after doing that arduous process, right? So what do you need to do? So we're going to take a real life job that I've actually done before. I work for a construction company that works mostly on what we call public domain and external works, which just has to do with things like roads and paving and stuff like that, okay? So in this case, we're going to do all of the first 5 processes that we learned the first 5 processes that you will learn in the course, and we're going to turn an old curb into a new curb like this, okay? So let's have a look and break this down first of all. Okay, so technical drawings like this are available if it's a public domains work, you can actually just search this up. So this is a curb and gutter design for Blacktown City Council. So you can legit just Google this and you'll actually get this on Google. You'll find it, right? So this looks very technical, but mostly it's just dimensions, right? This doesn't really give you that much context. So I'll have a drawing on the next slide that'll actually show you what this is all about, okay? But this is something that you'll have to interpret if you go into construction, right? You don't have to make these drawings, you have to be able to read them, okay? So what does that actually look like? Okay, so if you see along your road, right, you have the curb that is sticking up, and then you also have a little bit of concrete on the side. That's called a curb and gutter. So the curb is the part that sticks vertical, and the gutter is the side that is on the flat part next to the asphalt. So this is actually what it looks like. This is a cross section of what the road looks like when you look at a curb and gutter, right? So you might have some grass, some turfing on the side, and you have some soil underneath. And then you have your curb and gutter that is flush with it, and then you have your road outside. Underneath, we actually have a couple of different materials, right? So topsoil is one of them. That's just soil that we use for gardening, essentially. Below the asphalt and the curb and gutter, right? So the curb and gutter is made of concrete. Below that, we have this thing called road base. And road base is essentially just rock that is blasted from a quarry. And it's just little pieces of rock that they compact so that it makes a nice flat surface, right? And that surface will support the concrete and everything around it, okay? Below that, we have this thing called the subgrade, and that's just the natural rock or dirt below it, okay? So it's not quite topsoil, it's more compact than topsoil, okay? So that's what the drawing kind of translates to. Okay, so how do we actually build this? We have 5 different processes, right? So we need demolish, we need to do some earthworks, formwork, concreting, reinstatement, okay? Now, in your course, you'll learn about these in a bigger scale, right? So when you're demolishing, you're actually demolishing things like skyscrapers, big buildings. Earthworks, you're moving lots of dirt, right? Formwork, you're doing lots of big columns and things. Concreting, you're pouring massive slabs, and then reinstatement, you don't really touch on, right? But in this demonstration, in this part where we're doing this curb and gutter, it's a small scale job, right? It's not something that requires lots and lots of people on site. It's just something that's small and that can be done within possibly even a day if it really needs to be done, right? So, before we move on, some of the considerations for this, we need to think about things like site access. We also need to think about traffic. These are some things that you need to do that you actually won't learn about in this course, right? So I haven't really put that in there because I feel like it's not that important for you to understand. But when you do get into a job, that's where your engineering skills come from, right? You need to think about, okay, well, if this is on a main road, can I actually do it during the day, right? Because if you have to block off half the lanes just to be able to complete your works, it's probably not good during peak hour traffic, right? So you might have to resort to night works, other things, right? Okay, so how are we going to actually do this? Let's have a look at demolition first of all. So demolition. When you're demolishing concrete, concrete's really, really hard, right? So you can't just lift it out of the ground, right? So to actually demolish concrete, what we need to do is we need to cut it first, and then we need to hammer it with a jackhammer, right? So I've drawn a little 3D model of that 2D cross section, right? That purple line there is where we're saw cutting, right? So that's a small section of curb, but essentially what you're actually cutting is you're cutting across the concrete. Actually, is there a pointer? Can you guys see my cursor? Yeah. So you're cutting along the concrete here to make small sections. So these are relief cuts, right? And then also, you need to cut along the road surface as well. So the reason that we cut along the road surface in this case is we want to make sure that the curve and the concrete looks super, super nice, right? And you can't edge the concrete, you can't make it look super nice if there's a road in the way, right? So you actually need to get rid of some of the road, pour your concrete, make it look nice, and then put the road back in, okay? So we'll get onto that after. But essentially, saw cutting is almost a business in itself, right? To get a saw cutter out, they need to make sure that they have a generator and they have an electric saw. And that saw is made of diamond, has diamond a diamond disc, and that will cut into the concrete. And you can see how it's really, really wet here. It's not that they're doing it in the rain, but they actually hook it up to water. So the reason that they have water pouring out into the saw is number one, for heat management, because cutting concrete is really, really tough and it takes a long time. Right? So the blade will heat up and warp if you don't put water in it. Another thing is dust management. Concrete is quite toxic in its powdered form, right? The cement is made from silica, or has silica dust in it. And silica dust can cause silicosis and can give you lung cancer, basically, right? So if you know anyone who works in the tunnels, they have to wear basically masks all day because of the silica dust from the rock blasting, right? Concrete's the same. That's why you see people wear respirators when they're mixing concrete, okay? So after the saw cutting's done, we use a hammer or a jackhammer, right? And that can be on an excavator, right, as an attachment, or it can be done manually by hand. Usually if you're doing, let's say, 20, 30 meters of this curb and gutter, you might want to use an excavator, or else you'll take all day just to hammer it out, right? So we've got to think about efficiency, cost as well, right? So use a jackhammer, break up all the pieces, and they'll switch the tip into a bucket, right, into a bucket attachment, and they'll scoop all of that rubbish out, right? So the rubbish that they're actually scooping out is going to be the concrete itself, yes, but it's also going to be the topsoil behind it and the grass, as well as that road-based material, okay? So if we look back here, what we're getting rid of is we're getting rid of some of that topsoil here, we're getting rid of this concrete here, getting rid of all the road base and a little bit of that asphalt, right? So asphalt isn't just the road, yeah? We're going down basically to the subgrade, to the layer of solid dirt or solid material, okay? So once that's all excavated, then we can actually build our new part, right? So that's the demolition done. Okay, earthworks, right? In terms of shaping, curbs and gutters are pretty simple, right? You just shape out a rectangular portion, right? And you might use a small excavator like that for a job like this, or if it's a really, really big job, you might want to use a bigger excavator, right? That just saves you on time. The most important thing is to save on labor cost, to be honest. In terms of machine costs, it might not cost you that much. That machine might cost you about $400 a day. A bigger one, maybe $1,000, right? But labor on site will cost you a lot of money because you might need someone to excavate, you might need a spotter. That's $80 an hour. Over 8 hours you can calculate. That's a lot of money, right? So you want to get that done as quickly as possible and as efficiently as possible. Now, in terms of the earthworks that you're doing here, as I said, you're removing some of that back part, your topsoil, and you're removing a little bit of that road, okay? And the reason is, when we are actually putting in the formwork, you need space, right? You need space behind and in front, so you can actually put it in and you can form it up properly, right? Imagine you just cut out that concrete bit, you wouldn't have any space to put this wood, right? Because let's say this is a 600 mil section, that is already 50 mil, for example, you're not going to have it correct to spec, right? So you actually need to dig out a little bit more so that you can put it in. Yeah. Okay, so earthworks on this project, very, very small, right? Earthworks on it, when you learn it in the course, will be about very, very large quantities of soil, right? So think about flattening like a whole suburb, like for example, New Kellyville development, new places like that, or Austral, things like that. You might have big hills and things. You need to actually remove lots and lots of soil, and you need to place it in other places to make it flat, essentially. Now, you'll learn about all the equipment that you need for that, right? But the main piece of equipment is going to be an excavator, loader, right? Things like that. You'll learn about all that, so trust me, don't worry about that. But the process is, so far, we've dug out everything, and we're ready to put in our road base. So how does road base actually come about? Road base, or what we call DGB, densely graded base, is made from rock blasting, right? So it's a quarried material, which means it just comes from breaking rock, essentially, mining in Minecraft. If you break that down, you get this thing called road base, and it's about 20 mil in diameter, right? So the rock's not that big. You can hold it out, and it's like, you can hold it. That's loaded onto a truck, and that's like put onto site as well. Now, when you lay down that road base, right, it will have a lot of what we call voids. So it will have a lot of empty space in between the rocks. You can imagine the rocks don't tessellate very well, right? So that's why after we lay it, we have to compact it as well. This is a compactor, and basically you just put it around and it just like vibrates and it settles all that rock into a nice compact even layer. So when you walk on it after, you won't be able to kick up the rocks. It'll be pretty solid and firm. Okay, so that's Earthworks. After that, we do our formwork. So formwork consists of these like wooden bits here, right? These wooden bits and also these metal bits here. So the metal bits just add shape to the curb, and then the wooden bits actually hold that in place. So why is formwork so important here? Concrete flows, right? It isn't like Play-Doh, it flows more like lava, right? So when you pour concrete, imagine if you just poured it on the street, it would kind of turn into a pancake, right? So to have the concrete flow in the direction we want and to make sure that it holds the position that we want, we have to put in formwork. So this is a temporary structure, right? And in this case, it's made of timber, right? And what they'll do is, when you put down the timber, they'll also spray it with some stuff that is like a lubricant so that you can remove it later on, okay? If you're doing like a backyard pour, you can use something like vegetable oil, and you just like oil up the wood, and then you'll be able to remove it later easily, okay? Concrete's really sticky, so if you don't do that and you forget it, it's going to be a really bad time trying to remove the wood, okay? Now, usually, the formwork is made on site. So it's not going to be something that they buy off the shelf or they bring to site. They just bring wood, and then the tradies will basically cut the wood to length and make sure that it's formed up properly. Now, in terms of approvals, you need to make sure that you have your formwork approved by the client or the client before you actually pour the concrete, right? Because if you imagine, you can change the formwork, but once the concrete's in, it's going to be a big process to be able to change that, right? Sometimes mistakes do happen and you have to break the whole thing and redo it, okay? And that actually comes out of pocket for the contractor. So if you make a mistake, you fuck up, that's on you, okay? So you need to make sure that you read the specs properly and you make sure that you have allowance for mistakes and things. Okay, so after the formwork's up, concreting. We'll touch on concreting in a little bit, but there are some miscellaneous notes for it. Concreting here, actually, I'll skip to that part. I think it makes more sense now. Okay, so how does concreting actually work? Has anyone seen a backyard pour before, where they like put it in a wheelbarrow and like they just dump it in? Yeah, okay. So that usually doesn't happen on site unless it's a really small thing, right? So let's say that you're putting like a sign up, you might do it on site, right? If it is a bigger job, for example, like that curb and gutter we're doing, concrete is going to be done by an external factory, basically, right? Concrete factory like Boral or Holcim or, I forgot the other company. They're going to be the people who mix the concrete and they pour it on site, right? So has everyone seen this machine before? Yeah? So that's a concrete truck or a concrete agitator, right? So essentially, that brings your already mixed concrete to site, right? And then all they need to do is basically pour it out of the chute at the back, right? Now, this concrete machine, this agitator, right, will be pre-mixed at factory with a specific mixture, right? And you'll order that mixture. You'll specify everything for that, right? Now, concrete isn't made of one material, it's a mixture of materials. So that's why the barrel has to continue rotating to make sure that everything stays in suspension, right? So again, you'll learn this in the course, but concrete's made up of not only water, cement, sand, and also a large aggregate like rock, right? So once that's all kind of mixed to proportion in the truck, it starts a chemical reaction, right? So concrete doesn't dry per se, concrete cures, right? Which means that if you put water into a concrete mix, you can't just keep adding water to keep it going and keep it wet. It will solidify at some stage, right? So it's a chemical reaction between water and cement, and you basically have about 2 hours once the water touches the cement, unless you add retarders into the concrete mix, which will prolong the drying process. There are also other things that you can add to make it set faster, right? And depending on the type of work you do, you might need to have it set faster, okay? But usually 2 hours is good because the truck needs to drive to site and then it might need to wait a little bit before it can pour the concrete. So you need some time. So after you have your concrete on site, you might have a pump, right? So the concrete might come onto site and your pour might be 50 meters away, right? You can't bring the truck right to the place because there's no access. You can't drive the truck in, right? So what do? You might order a line pump or what we call a boom pump, which is on the next slide. And essentially that allows you to just pump the concrete from one place to another, okay? So your agitator truck will pour the concrete into this hopper here, and that concrete will be pumped all the way to wherever you need it, right? And then we have a concreter or pumpy, and they'll pour it on site over this part here, okay? So that's a line pump. So line pumps go along just the surface of the road or the site. Boom pumps go overhead, okay? So usually boom pumps are used where there is no line of sight access, or you might need to go up a few stories, right? So boom pumps will basically be used during that time. And they typically are more popular because it's easier to set up. The boom pump doesn't actually need to park inside. It can just park just off site a little bit, and then you can just boom all the way in, right? So even residential backyard pours, if you're pouring a big slab, right, big patch of concrete in a backyard, you might have your boom pump right at the front gate and you boom all the way at the back, right? Okay, so you might have seen that concrete isn't just concrete by itself, right? It isn't just poured by itself. In this image here, we have this mesh here. So I'll just show you what that mesh is. So that mesh is reinforcement, okay? And it's typically made of steel, although there are other materials, but you will learn about steel reinforcement in your later years. So steel reinforcement is very, very important for certain concreting tasks, right? In our curb and gutter part, it's not that important, right? Because we don't have any loads on it. But concrete, if we squish concrete together and we stand on it, it's very, very good in compression, okay? But concrete is not so great in tension. So if you try to rip concrete apart, it will break very easily, right? So if you think about, if you heat things up, things expand, right? So in the summer, if you have concrete in a really, really hot location, it could actually pull apart and crack, right? So what we need to do is we need to add rebar or mesh, right? And it's just steel reinforcement that goes in between the concrete, right? So inside the concrete. And what that does, it just adds some tensile capacity, right? So it adds improvement. It allows the concrete to be able to work in tension a little bit more. Okay. Okay. So anyways, we don't need reinforcement for our one. But what we do need to do is we need to screed and level, right? So when your concrete's poured in, as I said, it becomes like a bit of a pancake, right? And it is a little bit thick, so sometimes it can have high spots and low spots, right? So screeding and leveling is done for all concrete works. And essentially what that means is you're taking a piece of wood, or in this case they have a screed tool, like a specific tool for it, and you're just striking off any of the parts that are high and putting it into the low spots, right? You're just kind of leveling that concrete, right? And someone comes here and they can kind of move more concrete with that rake, and they'll just level it all out, make sure it's roughly even, right? So that's level. Okay. After you level it, you need to float the concrete, right? And floating just means making sure that the surface is nice and smooth, okay? So it involves kind of using these like flat aluminium or steel trowels, and you're kind of just brushing it over top and making it nice, like icing on a cake, just smoothing it out, right? So after you get all the rough spots out, you smooth it out, and what we do this thing called bringing the cream to the top, which essentially just means like the little watery bits of concrete. So just make sure you don't have any rocks sticking out, essentially. So that's floating, right? And you don't really stand in the concrete after this part, right? So that's float. After floating, you also need to put some control joints in, okay? So concrete will crack no matter what you do, okay? What these control joints do, or what these dummy joints do, is we allow it to crack in a controlled manner. We want it to crack in certain places so that it doesn't look visible on the surface. So have you guys driven across curbs and they have like, or footpaths and they have like lines in between? But you see that it's not actually an actual cut in. It's just like a divot kind of thing. That's a control joint. And they do it when the concrete is still partially wet, right? So they'll put that tool in and they'll basically cut it across, right? And it's both for aesthetics and also is a bit more functional. You don't have to replace the concrete as often. Okay. And then after that, you don't want your concrete to be too smooth, right? Unless maybe you own a warehouse or something. For most things, you want your concrete to be grippy, right? If you walk over it, right, you want it to be grippy. For our curb and gutter, you actually don't do that. You make it look nice and smooth, right? But if you're pouring a footpath, for example, you have a broom and you'll just broom it across so that it has a bit more rough surface to it, okay? And that just allows people to walk even when it's like wet so they don't slip, yeah? So that's a part of the safety part. Okay, and that's basically the last part of concrete, right? And you're done with that. So taking that back to our example, in this case, when we're pouring this concrete curb here, right, we'll have an agitator come in on the day, and if it's a long bit of concrete there, you might have a boom pump or a line pump, right? And you'll have a line pump and you'll pour the concrete along the whole surface here, right? And you'll have manual labourers come in and shake the concrete. They'll smooth it out, level it, screed it, and then they'll also float the concrete, right? Now, most curbs and gutters that you see, they don't have a rough surface, as I said. So you just float it and you're done, right? You make sure it's a nice smooth surface and that's it, okay? Now, with things like this, curb and gutter, they look the same everywhere, right? So a lot of the time, they'll actually use a thing called a curbing machine. And you basically just pour concrete into that hopper and it will pour it and form it for you, right? So it just reduces the amount of labor. So if you're doing like 100 meters of curbs, then yes, you might use a machine for it, okay? Okay, so that's concreting done, right? Concreting is done here. So after the concrete's done, you can let it set overnight, and then the next day, tradies will come back in and they'll remove the wood, right? So hopefully you oiled up the wood so you can remove it easily. Once you get rid of that, your concrete's basically set, right? And after your concrete's set, you just need to put everything back in place, reinstate, right? So this part here needs to be put back together, right? So people don't trip over it, and then grass needs to be put over there to make it look nice, okay? So if you work in industry, you'll hear this term called make good, which sounds bloody stupid because it kind of is. But that just means to reinstate to its original condition, okay? In this case, we've cut out 2 bits. We've done earthworks on 2 bits. We just need to replace these bits here. So in terms of what we fill in for each of these sides, if it's a lawn on this side, right, if it's a nature strip or grass, all you have to do is pour soil into this back section, fill it up, and then put grass over top. And the grass will grow and hold the soil in place. That's it, right? For this front part, it's a little bit more complicated. So what you will need to do is, you'll need to take your road base and fill it up all the way to the top almost. Leave about 5 centimeters, and you need to pour asphalt, right? So you need to redo the road along there, okay? So I'll reiterate again with the reason that we did that. We want the concrete to have a nice smooth finish, right? So we want to make sure that the edges are super nice, right? So that's why we cut out the concrete, the asphalt in the road. We need to replace the road base, and then we need to pour the asphalt again for that. But usually that can be done maybe a week after. Actually, no, a couple days after, and that's fine. Now, this is a very stock standard job, and it's a very simple job. Sometimes you might get asked to replace a curb and gutter on a main road, Transport for New South Wales main road, right? You don't have the time to be able to do all this nice stuff here, right? So if you're doing it overnight, the process is basically the same, but instead of over multiple days of forming it up and doing everything, you do it in one night, right? So what that looks like is usually double the cost because you need double the manpower or double the machinery cost as well, okay? If you're doing a big chunk, you're going to need bigger machines because you need to get the job done faster. Time is of the essence. You won't be able to cut the asphalt because you can't pour asphalt when the concrete's still wet. So what the government will actually do is they'll be like, oh, just make it as good as possible, right? Don't worry about the finish on the edge there, just make it look sort of okay. Yes?
Would the concrete cost more as well? Because you know how you said like you don't order specific concrete to like dry fast and stuff.
Yeah.
Does that mean like for an overnight job you need to order a specific type of concrete and then like cost extra, or is there a different thing?
To be honest, concrete can actually dry within, oh sorry, not dry, cure within 2 to 4 hours.
Sorry,
Yeah. So it can cure within 2 to 4 hours, right?
Okay.
So if you start the night works at 9 p.m., you can basically open the road by about 5 a.m.
Okay.
Right? So what that might consist of is 3 hours of like digging it up all up and then forming it up, and then it might take another 2-3 hours to pour it and then clean up, essentially, right? But yeah, in terms of quick set, no, you don't need concrete to set quickly. But usually the added costs are going to be opening the plant, because the concrete plant only opens from basically like 6 till 6 p.m. Right? So after that, you actually need to open the concrete plant up, so that's another fee on top of it. Then you need to order the minimum amount of concrete, and then they have to have an overnight driver and all that sort of stuff as well, right? Yeah. Now, how do you know if your concrete's the right strength? I haven't added it here, but there is this thing called a slump test. Okay, have you guys heard of that? Maybe not. Yeah, it's like a little bucket thing. Yeah. So I'll show you some tests.
They have rings and like
Yeah.
tests too.
Okay, maybe not with a human. Okay, this one. They have this cone thing, right? Why are all these shit photos? Okay. Maybe this is a good photo. Actually, this is a good photo. Okay. Okay. So, ignore these last two, right? If this is your concrete, you're fucked, right? You can't pour that, you have to send it back. But essentially, the bigger the slump, okay, so actually how is slump measured? Slump is measured from the height of the cone to the actual true height of the concrete after you take it off, right? So see this guy, how he's measuring it here. Sorry for the shit photos, but that is the slump there, right? From the top of the concrete when it comes out of the cone to the height of the cone, right? So that's what slump is, right? So if you can imagine, the lower the slump, the more stiff the concrete is. The higher the slump, the more flowy it is, right? So with concrete, you have to have a specific slump as per the specification. They'll tell you everything, right? They'll tell you how to mix it, like what mixture and everything. You just send that to the plant will do it. But when you come on site, you still have to make sure you do a slump test, right? To make sure that the concrete is of the correct strength. If you add too much water, you can imagine it will be very diluted and it won't be very strong, right? So you need to have it within a certain slump tolerance. And usually what the plants will do is they will add less water than you told them. Because they know that on site, tradies like to put a lot of water in. And the reason that they like to put water in is because it flows quicker and it can be done quicker, right? But that is not a good way of doing things, right? So that's why they have a tolerance for how much water you can actually put in, okay? You can't be pouring it's like water onto site. Okay, so continuing. So after you do your slump test and you pour your concrete, yeah, a lot of the time, overnight jobs, you won't even cut this asphalt here. You just cut it along there and then just pour the concrete as is. Make it as good as possible and then leave it, right? So it can be done like that depending on the circumstances, right? Yeah. Okay, I think that's it actually. That's it for building a curb and gutter. So that's basically all 5 of the processes that you will learn about, but actually on a real job. So yeah, that's it for me today. But yeah, if you have any questions, please let me know. I'm happy to go through anything again for that. Yeah, thanks guys.
Thanks, Dom.
Yep.
Was that like 1 week's worth? Like how many weeks worth of content was that? Like
5 weeks of content.
Oh, okay.
Yeah. Again, I didn't want to bore you with a lot of technical detail, but this is kind of how everything plays in together, right? On big jobs like you'll learn about, you'll have basically one company do each of these things, essentially, right? You might have a company that specializes only in what we call bulk excavation or bulk earthwork. And basically all they do is they have excavators that just fucking flatten land, right? And you have other companies that will just do fucking concreting. They'll just pour, that's it. You have form workers that just do form work and put up all the structures and that's it. Yeah. Yep.
For formwork, does that fall just under like temporary structures and not go into concreting and earthworks?
That's temporary structures. Yeah. So this is formwork for concrete is one of the types of temporary structures you'll learn about.
And in the beginning, you mentioned like about the tendering and the subcontractors,
Yeah.
contractors, and clients. Is that not like part of what we're taught in the actual?
Unfortunately, it isn't.
That's just like info on what is done before like the demolition earthworks.
Yeah. That's the unfortunate bit. They don't really teach you about the logistics about how jobs get won and things like that. That's more of an elective in 4th year. If you want to do like contracts, I think there is a thing for that. So you can try that. But yeah, they don't really teach you that. They teach you about the processes that actually happen on site. So in terms of the job that we just did, we've worked on all these things. So demolition, earthworks, and then we do formwork, concreting, and then they don't really do reinstatement, but yeah. So after concreting is done, that's a permanent structure. It stays there forever, basically. Yeah. But yeah, hopefully that was understandable for you guys. But yeah, I'm done, basically. Yeah. Any other questions? That's it. Okay.
Alright, we've got a 30-minute gap between now and the next workshop. If you're staying around for 1300, but yeah, you guys can go or do whatever you got to do.
It's so cool.